Well, that's the problem. The James Webb Space Telescope is upsetting the apple cart. All of a sudden, we realize that we may have to rewrite all the textbooks about the beginning of the universe. Now, it takes many billions of years to create a galaxy, like the Milky Way galaxy, with 100 billion stars, many billions of years old. But the James Webb Telescope has identified six galaxies that exist half a billion years after the Big Bang that are up to 10 times bigger than the Milky Way galaxy. That shouldn't happen. There should not be primordial galaxies that are bigger than the Milky Way galaxy that are only half a billion years old. Something is wrong. We may have to revise our theory of the creation of the universe.
What if the story of our universe, the one we have held onto for decades, is fundamentally wrong? What if the Big Bang wasn't the neat starting line we always imagined? The James Webb Space Telescope, our most powerful eye on the cosmos, has just sent back signals from the dawn of time that could shatter everything we thought we knew. Staring back at us are structures so massive, so bizarrely mature, that they simply have no right to exist in the infant universe. They've been nicknamed the universe breakers, and they seem to have formed at a speed that defies our cosmic timeline. It's forcing scientists to ask an extraordinary question. Is our rulebook for the universe itself deeply flawed? To understand just how revolutionary this is, you have to appreciate the machine at the heart of it all, the James Webb Space Telescope. This isn't just an upgrade to Hubble, it's a genuine time machine. With its huge golden mirror, it's designed to capture the faint, ancient light that has been traveling for over 13 billion years. Light from the very first galaxies lighting up the cosmos. And it's doing its job better than anyone could have possibly dreamed. The trouble started almost immediately. Astronomers expected to see cosmic infants, small, messy, disorganized clumps of stars, the first shaky steps of galaxy formation. Instead, Webb started finding what looked like full-grown adults in a cosmic nursery. Galaxies that were shockingly large, brilliantly bright, and far more structured than our theories could explain. And then, in May of 2025, a discovery was announced that sent a fresh shockwave through the scientific community. A team using Webb confirmed the existence of a galaxy named MOM Z14. Its light travelled for over 13.5 billion years to reach us, which means we're seeing it as it was just 280 million years after the Big Bang. As of right now, it is the most distant galaxy ever confirmed by science. It's a ghost from the absolute dawn of time. But this is no faint ghost. It's blazing with the light of furious star formation and has a mass that rivals the small Magellanic Cloud, a companion galaxy to our own Milky Way. Finding a galaxy this substantial, this active, so early in the universe is like finding a fully built skyscraper in a settlement that was supposed to be nothing but mud huts. And MOMS 14 isn't some lone curiosity. It joins a growing list of cosmic anomalies like jwst 13-1, seen at 330 million years after the Big Bang, and other so-called universe breakers. These aren't just oddities, they are clues that are turning our neat and tidy timeline of the cosmos completely upside down. To really get why these discoveries are so jaw-dropping, we need to talk about the official story they seem to be breaking, the standard model of cosmology. Think of it as the universe's official biography. It's a theory that has been wildly successful, explaining almost everything from the leftover heat of the Big Bang to the grand web-like structure of galaxies we see today. The story goes like this. Around 13.8 billion years ago, the universe exploded into being. For the first few 100,000 years, it was an unbelievably hot, dense soup where light was trapped. As the universe expanded and cooled, atoms formed, and it entered a period known as the Cosmic Dark Ages. For hundreds of millions of years, there were no stars or galaxies, just vast, silent clouds of hydrogen gas drifting in the darkness. Eventually, gravity started its slow, patient work. It began pulling the densest clumps of gas together. Over immense timescales, these clumps were supposed to ignite, forming the very first generation of stars, called population 3 stars. These stars would then gather into small clusters, which would merge into small dwarf galaxies. Then, over billions of years, these dwarf galaxies would collide and combine, gradually building the magnificent galaxies we see today. The key word here is gradually. Our models have always predicted a bottom-up formation, where big things are built from small things over a very, very long time. But Webb's discoveries are turning that expectation upside down. The universe breakers are not small and they are not primitive. They are massive and chemically mature. For instance, observations of some of these very early galaxies show signs of elements like nitrogen. Nitrogen has to be forged inside stars and then scattered when they die. Seeing it this early means at least one full generation of stars had to form, live, and die, all within an incredibly short window of time, a process we thought should have taken much longer. Then there's the puzzle of the cosmic fog. That thick fog of neutral hydrogen in the early universe should have blocked certain kinds of bright ultraviolet light, like the Lyman alpha emission that comes from hot, young stars. Scientists believe the fog wasn't fully cleared until maybe a billion years after the Big Bang. Yet, a galaxy like JADES GSZ 131, at just 330 million years old, is shining with incredibly strong Lyman alpha emission. It's as if this tiny galaxy is a lighthouse that has somehow punched a giant hole in a fog that should have been impenetrably thick. The reaction from scientists has been a mix of exhilaration and total bafflement. This is what happens when a powerful new instrument comes online. It breaks things, and breaking things is how science moves forward. But the sheer scale of this discrepancy has left many stunned. One researcher famously compared it to finding a fully grown adult in a nursery. It just doesn't fit the growth chart. At first, some thought there might be a mistake. Measuring cosmic distances is a tricky business based on redshift, the stretching of light as the universe expands. A closer galaxy that's just really dusty can sometimes trick us by appearing very red, mimicking a more distant one. However, for many of these key objects like MOM Z14 and the JD's Galaxies, follow-up observations with Webb's powerful spectrographs have confirmed their extreme redshifts. They really are that old. This has kicked off a scramble for answers. The phrase crisis in cosmology has been used, though many scientists would say it's not a crisis so much as a profound and exciting puzzle. We are now faced with two main paths. Either our understanding of how galaxies grow is seriously incomplete, or there's something wrong with the bigger picture, the standard model of cosmology itself. Now we're going to dive into the leading theories that could explain these cosmic paradoxes, from small tweaks to our models to ideas that sound like they're straight out of science fiction. These discoveries are happening in real time and could rewrite our textbooks. If you're enjoying this journey into the unknown, make sure you hit that subscribe button and ring the notification bell so you don't miss what we find next. The first and most conservative idea is to assume the main rulebook is correct, but we've been misreading some key chapters on how stars and galaxies are born. Maybe the first stars, those population 3 stars, were even more extreme than we imagined. Our models predict they were giants made of pure hydrogen and helium, burning incredibly hot and living short, violent lives. But what if they were even more efficient at forming and even more colossal than predicted? A galaxy packed with these superstars would look far brighter and more massive, which could explain what Webb is seeing. Furthermore, these gargantuan stars would have blasted out a torrent of radiation. This could explain how galaxies like Jade's GSZ 13-1 cleared out the cosmic fog around them. They might have acted like an army of cosmic leaf blowers, creating huge bubbles of transparency in the otherwise opaque universe, letting their light escape to reach us. Another idea is that the seeds of galaxies, supermassive black holes, didn't start small. Our models usually suggest black holes form from a single collapsed star and grow over billions of years. But what if they can be born big? Some theories propose that in the dense early universe, enormous clouds of gas could have collapsed directly into a massive black hole, skipping the star phase entirely. This would give a galaxy a huge head start. A massive black hole at the center would act as a powerful gravitational anchor, pulling in gas and accelerating star formation to a fever pitch. In fact, some analysis suggests the extra brightness in these galaxies might not be from extra stars at all, but from the brilliant light of matter being devoured by these oversized infant black holes. If true, the galaxies aren't actually breaking the mass budget. They just have very bright, very hungry engines. Before we throw out the textbooks, scientists have to rule out every other possibility. And one very real possibility is that some of these objects are just cosmic imposters. The Mirage or Miracle survey that found MOMZ 14 was named for this exact problem, to figure out if these objects are a miracle, a genuinely ancient galaxy, or a mirage. A mirage can come in a couple of forms. The most common suspect is a closer galaxy that is just incredibly thick with interstellar dust. The dust blocks all but the reddest light, making the galaxy appear extremely red, which can fool us into thinking it has a high redshift. It's a classic case of mistaken identity. While spectroscopy has ruled this out for famous examples like MOMZ 14, it's a constant concern. Another possibility is gravitational lensing. As Einstein predicted, the gravity of a massive object can bend space-time itself. If a distant galaxy is hiding behind a massive foreground galaxy cluster, its light can be bent and magnified, making it appear much brighter and bigger than it really is. Webb actually uses this trick to its advantage, but it can also complicate things. It's possible some of these universe breakers are less massive than they seem, their light simply amplified on its long journey to us. This is where things get really interesting. What if the problem isn't with the galaxies, but with the universe itself? What if they aren't breaking the rules, but are revealing that the rules we thought we knew are simply wrong? One of the most provocative papers to come out in the wake of these discoveries was from a team led by Martín López Corredera. They analysed a sample of massive galaxies from Webb's data and estimated the age of their stars. Their conclusion was startling. They calculated that the stars in some of these galaxies appeared to be between 900 million and 2.4 billion years old. But the galaxies themselves existed when the universe, according to our standard model, was only about 600 million years old. This would mean their stars formed hundreds of millions of years before the Big Bang. Now, on its face, that's impossible. And to be crystal clear, this is a highly controversial idea, and most cosmologists believe the answer lies in flaws in our models of stars, not in upending the Big Bang. But López Corredera and his team suggest this paradox might point to a flaw in our cosmological model itself. They point to alternate models where the universe might be much older than the standard 13.8 billion years. In such a model, there would be plenty of time for these stars to form. This doesn't mean throwing out the Big Bang, but it could mean fundamentally rethinking what came after. More speculative ideas are now on the table. Could dark matter have had different properties, allowing it to clump together much faster? Could our universe be part of a cycle, with these mature structures being relics from a previous cosmic era? This is deep in the realm of theory for now. But the fact that credible scientists are even publishing these ideas shows just how seriously this challenge is being taken. These galaxies are forcing us to ask the biggest questions. The truth is, we don't have the answer yet. We have a collection of beautiful, impossible-looking objects and a growing list of fascinating, competing theories. This moment in cosmology feels like a detective novel where the crucial, baffling clue has just been discovered, and now all the investigators are racing to see who can solve the case. The key will be more data. For every one of these universe breakers, astronomers are conducting deep spectroscopic follow-ups. This lets them not just confirm the distance, but dissect the light itself, analyzing chemical composition, temperature, and the ages of the stars inside. This will help them tell the difference between the theories. For example, if the extra light is from a hungry black hole, the spectrum will look very different than if it's from a cluster of supermassive stars. The James Webb Space Telescope is still just getting started. As it stares deeper into the cosmos, it will find even more of these objects, pushing the frontier even closer to the Big Bang. Each new discovery will be another piece of the puzzle, either strengthening one theory or just maybe breaking our understanding all over again. What we are witnessing is the scientific process in action, live on a cosmic scale. A theory that has stood for decades is being pressure tested by an instrument of unbelievable power. The discovery of galaxies like MOM-Z14 and JD's GSZ13-1 hasn't broken cosmology, but it has cracked it wide open, revealing huge gaps in our knowledge and forcing us to imagine new possibilities. Are they the result of a star formation process that was simply more rapid and violent than we ever expected? Are they optical illusions created by supermassive black holes? Or are they signposts pointing to a new, deeper understanding of the universe, one where the beginning was not as simple as we once believed? The only thing we know for sure is that the universe has once again proven to be more complex, more mysterious, and more wonderful than we ever dared to imagine. What do you think is the most likely explanation for these impossible galaxies? Let us know your theories down in the comments below. Thanks for joining us on this journey to the cosmic dawn. And make sure to subscribe before the universe rewrites another textbook without you.